everyone. I hope you can hear me okay. Um, yeah, so I tell you a little bit about BeamSea Associates, and we're really a maritime photonics and laser company, and we have a small team, and expertise is really in underwater LIDAR and underwater, free space optics in general, including laser communications. And we um, bear with me. Yeah, so I'll just give you an overview of the company, and then what we've been concentrating on developing our commercial offerings, and then some of the other things that we're interested in partnering with other people to progress. But we've been working for about 5 years on the core technology, and on several contracts where we're been developing a type of LIDAR for underwater that really performs better than the other architectures we've experimented with in turbid water. So it's really focused on extended range in turbid water. And we've developed, in up to sort of 20 years ago, working in universities, the team have developed and validated some radiative transfer models that, and modeling software tools that allow us to predict performance of different LIDAR architectures in scattering waters. And so we've developed this and miniaturized synchronous scanning active electronically steered array LIDAR system, and we just call it the pulse laser line scan. And we have some payloads that are available commercially. They're for small UUVs, so vehicles like the Remus 100, the Ivor 3, Ivor 4, Gavia, Bluefin 9, Groltech, and Sieber. There's other small UUV manufacturers that we're also working on developing this LIDAR for micro UUV platforms. So some of the even smaller ones are approximately the size of a sonobuoy, an A-size sonobuoy, like the TDSX Barracuda, the EcoSub, Sieber have a small vehicle that size as well. And we have some other interesting developments that are not commercially available on that combine optical imaging using LIDAR techniques with laser communications. So let me just show you an example of some imagery. That this is a single pass where we have the 120-degree pulse laser line scan on a Remus 100. It's a wreck site off the coast of Florida. And so here we're instantaneously, our cross-track dimensions about 12 meters. So we have a long, a wide swath, wider than you would get with a camera, and we're about 6 or 7 meters off the bottom. And the top figure is intensity. The middle figure is the range map, and then this is just the commercially available unit that we have that can do this. Also, for clearer water, when you're closer, it has a camera as well and strobe. So you can co-align and co-register the LIDAR 3D point clouds with color and correct the color to have a sort of true color rendition of the scene. There's another example with this is a situational awareness type payload. It's a 360-degree LIDAR, and we had this, and we were using it the intercoastal water in Florida. And this is just showing this. So, for example, figure E and F, where we've co-registered the side scan sonar with the LIDAR, and you can just sort of see the improvement in this, what we're getting with the LIDAR. But typically the LIDAR would work alongside acoustics, because in the very turbid waters, you would be relying on the acoustic sensor by itself. And yeah, this is just I'll go through some of the performance parameters of the system. So this is what the payload looks like, and it goes on to a torpedo-shaped UUV. Could go on to unmanned surface vehicle, and also like an ROV. But we have our point cloud density. We're doing about 1 million points per second, so it's very high point cloud density compared to what's currently available. And it's just a gigabit Ethernet or a USB device. This the version, it's 6 inches diameter, so 152 millimeters, and about 350 millimeters in length. And it can be co-located with a camera. And we provide like the software to view the LIDAR imagery after a mission, and to export it to different point cloud viewing softwares. So I'll just show you some of our longer term goals, where we're wanting to combine LIDAR imaging in turbid conditions with with ways of I think it's really to answer this. The challenge is that underwater optical imaging, you just look at one small patch at any one time, and we're trying to, for some missions, it's important that you could look at bigger patches. If you're looking at some events that are happening, you need a more synoptic view. So I think the video is jumping a little bit, but what we're trying to show here is, with a generic UUV platform, that there's multiples of. They probably have some acoustic connectivity, but in order to use this short range optical connectivity with low latency, there's some behaviors, autonomous behaviors and synchronization that needs to be developed. And our architecture the core technology that we're working on is future compatible for these types of applications, and developing new capabilities in robotic sensing is really our longer term goal. And we are seeking partners who want to work on these types of things with us. We have a solid core technology, and we have some very strong simulation tools to explore these types of scenarios. And I just wanted to share with you a little video that we put together of our system deployed on a blue boat from Blue Robotics. And I think the video is jumping a bit, but this is local to us in Palm Beach, and it's fairly turbid water, but we this type of imager, even with there's strong sunlight and it's turbid water, we can still get very high resolution 3D point clouds with our technology. So we're quite excited about that. Well, if there's any questions, I would like to take them.
Thank you, Fraser. Thank you very much for your presentation. Any question for Fraser? You mentioned that you are looking for some partners for your project. What kind of partners are you looking for today?
Well, we're certainly not a platform provider, and so I think we're we platform providers. There's in small UUVs there's quite a few offerings now, and I think having a platform provider and having customers that have a certain application, and we have some applications in mind that where being able to visualize larger swaths of the seabed in real time and relay that information with low latency to a surface asset could be a game changer. And I think that could apply to marine science, even commercial type oil and gas type work, and even for military. So I think just partners for further research and development. And we've just focused on developing the LIDAR payloads for UUVs, and that's our main focus as we move into production. But the R&D to fully realize the potential of this technology, I think that would be a team effort, and be partners in marine science, and engineering teams that develop platforms and autonomy algorithms and signal processing, communication protocols. So
and
I think there's a lot.
Yeah, so are you open also to work with European companies or European Research and Development Center, for example? Something that you would be open to do?
Yes, I think we certainly are. We have there's an operational capability that we're building up over in the north of Scotland.
Okay. Okay, good, Fraser. Thank you very much again for your presentation and participation. Thanks a lot.